Have you ever stopped and wondered how a tiny plastic groove can somehow recreate an entire orchestra? Or even your favorite singer's voice? It almost sounds impossible. There's no battery inside a vinyl record, no computer, no hidden speaker, just a spinning piece of plastic with microscopic grooves carved into it. So, how can something that simple play music with incredible detail? The answer begins with one surprisingly simple idea. Sound is nothing more than vibration. Here's an easy way to picture it. Imagine stretching a thin sheet of rubber across the end of a tube. Now, speak into the tube. As your voice travels through the air, that rubber sheet starts vibrating. Those vibrations perfectly match the sound you're making. In fact, your own eardrums vibrate the exact same way every time you hear someone speak. Now imagine attaching a tiny pen to that vibrating sheet. If you held a piece of paper still, you'd just get a messy scribble. But if the paper slowly moved underneath the pen at a constant speed, that scribble would suddenly turn into a smooth wave. That wave is a picture of your voice. You've just recorded sound. The only problem? It's just a drawing. You can't hear a drawing. But what if, instead of drawing the wave with ink, you carved it into a surface? That's exactly what inventors realized more than a century ago. Early record players used a large recording horn to collect sound and focus it onto a thin diaphragm. As someone sang into the horn, the diaphragm vibrated. Connected to that diaphragm was a sharp needle. As a wax disc spun underneath it, the needle carved tiny grooves that perfectly matched every vibration of the original sound. Every high note, every low note, every tiny detail. Once that wax master was finished, it was transformed into a metal mold that could press thousands of identical copies into vinyl. So now you have a record full of microscopic grooves. But how do those grooves become music again? The answer is beautifully simple. Just reverse the entire process. Spin the record at the exact same speed it was recorded. Place a needle inside the groove. As the groove moves beneath the needle, every tiny bump and curve forces the needle to vibrate exactly like it did during the original recording. Those vibrations travel into another diaphragm, recreating the original sound waves. Early record players simply used a giant horn to amplify those vibrations naturally. No electricity required, just physics. Modern turntables still follow the same basic idea, but instead of using a horn, they generate electrical signals. The vibrating needle moves a tiny coil between powerful magnets. Whenever that coil moves, it creates electricity. That electrical signal travels to an amplifier and then to your speakers, where the speaker cone vibrates exactly the same way the original singer's voice did. And just like that, music comes back to life. But vinyl wasn't the end of the story. During the 1980s, cassette tapes became the new king. Instead of carving grooves into plastic, engineers discovered a way to store sound using magnets. When someone records into a microphone, the microphone converts sound vibrations into changing electrical signals. As magnetic tape passes over a recording head, those electrical signals create tiny magnetic patterns across the tape's surface. Think of it like invisible ink made from magnetism. When you play the tape, a playback head detects those magnetic patterns and converts them back into electricity. That electricity powers a speaker. The speaker vibrates. Your ears detect those vibrations. And once again, you hear the original music. Then came another revolution: compact discs, or CDs. Instead of storing sound as grooves or magnetic fields, CDs store information digitally. The microphone still creates an electrical signal, but this time, a computer measures that signal thousands of times every second and converts those measurements into billions of ones and zeros. A powerful laser then burns microscopic pits onto the surface of the disc. Those pits are so incredibly small that the CD feels perfectly smooth. When you insert a CD into a player, another laser scans those pits while the disc spins. The reflected light tells the player whether it's reading a 1 or a 0. Those numbers are then sent to a device called a digital to analog converter, or DAC. The DAC rebuilds the original electrical signal. That signal reaches your speakers. The speakers vibrate. The air vibrates, your eardrums vibrate, and your brain hears music. Whether it's a vinyl record, a cassette tape, or a CD, every audio format follows the exact same goal. Capture vibrations. Store those vibrations in a clever way, then recreate them so accurately that your ears can't tell the difference. It's amazing to think that every song you've ever loved is really just millions of carefully preserved vibrations, waiting to come back to life the moment you press play.